Hello guys, so we are back again, and in this session we are going to continue with the second order and higher order derivatives, partial derivatives. In the previous two lectures we have done some questions regarding the higher order derivatives, and as we proceed deeper in the second order and higher order derivatives, the toughness level will increase significantly. So this is the third lecture in which we are going to solve some more variety of questions on higher order derivatives. So before starting with the lecture, don't forget to subscribe the channel Omega Pi IIT JEE and GATE, and share it with your friends so that they can also secure a good marks in their engineering examinations. So the question which we are going to take is as follow. The first question says as follow: if u equals to f of r square, where r square equals to x square plus y square plus z square, prove that dou square u by dou x square plus dou square u by dou y square plus dou square u by dou z square equals to 4r square f double dash r square plus 6 times f dash r square. Now first we are going to write that f of r square this and this stuff. Okay, after noting down this thing, we are going to tell that u is a composite function of x, y, z, right? Where u first is a function of r, where r is a function of x, y, z. Now we want this, and we know since the function is this type of function are called this. If you draw the curve, if you plot its graph, they are symmetric functions. So if I find dou square u by dou x square, similarly I can write that for dou square u by dou y square, dou square u by dou z square. So partially differentiate u with respect to x. What we get? Dou u by dou x. Always try to practice writing the curved d, because the curved d is a partial derivative sign, while the straight d is just a simple derivation. If you do these mistakes, at some point the teacher will ignore, but after some time he will start cancelling marks if you do it throughout the problems. Now what it will be? It will be dou by dou x into this f of r square, which will be, if I solve, I am going to get f dash r square into 2r into dr by dx. Right? Now what our main aim is to get this dr by dx. I know r is what? Under root x square plus y square plus z square. Let's call it as 1. So dr by dx will be what? 1 by twice under root x square plus y square plus z square, and by chain rule here it will be 2x. Then after differentiation it will be x by under root x square plus y square plus z square. Now we can call this stuff as r, so this will become x by r. Further on, since this function is symmetric, similar will be true for dr by dy. We would need dr by dy, dr by dz. So dr by dy equals to what? Y by r. Dr by dz will be z by r. This, how I can write this? Similarly. Now let's substitute dr by dx in this stuff. So what we are going to get is dou u by dou x will be nothing but f dash r square into 2r into x by r, which will give me finally x into f dash r square into r. So we are done with this stuff. Now let's r will cancel out here. There will be no r. It will be 2x f dash r square. Now let's call it as 2. Partially differentiate. What? Differentiate 2 with respect to x. Why we are doing it? Because in the proof we want second order partial derivative. So it will be dou square u by dou x square, which we will write dou by dou x into dou u by dou x, which if I differentiate partially by what? By product rule, it will be simply, I will keep the 2 outside, it will be x into dou by dou x into f dash r square. Further here it will be f dash r square into dou by dou x into x, right? After this 2 will be here it will be f double dash r square into 2 r square r square, since it is a function of this. Okay, I will differentiate it, so it will be 2r, then it will be dr by dx. Further on here it will become 1, so I will be left with f dash r square. Simple. Now what is going to happen is here it will be, I will substitute the value x by r, and it will become x square f double dash r square. This r will nullify, okay, and giving me finally this stuff. Further on, now we will multiply this, giving me finally 4x square f double dash r square, right, plus f dash r square, provided here 2 is multiplied. Now I will call it as 3, which will be dou square u by dou x square. Now we will say similarly what? Similarly, dou square u by dou y square will be nothing but 4y square f double dash r square plus f dash r square into 2. Okay, so this will be my fourth equation. And similarly, dou square u by dou z square will be 4z square f double dash r square plus f dash r square into 2. Okay, this will be my fifth equation. Now if you move ahead, we are going to see the proof, which says that you have to add all the third, fourth and fifth equations to get the required proof. So what will be our next aim? Our next aim is probably going to be write this dou square u by dou x square plus dou square u by dou y square plus dou square u by dou z square, which will be nothing but if we add on. Okay, now I am not going to substitute the values as I have done in the previous question. I am going to apply the logic. We are going to probably directly add this. Okay, so which will be 2 plus 2 plus 2, which will be 6, and here it will going to be 4 plus 4 f dash r square will take common, and there will be x square plus y square plus z square, which will be left. So here 6 f dash r square, yeah, as per this. Now what I am going to take common, 4 f double dash r square. Here the left thing will be x square plus y square plus z square, and if you observe the question carefully, here it is x square plus y square plus z square is nothing but r square. So I am going to get what is this 4 f double dash r square, and here it will be r square. Okay, so I am getting the final answer, which is the required this answer. So hence we have proved the required answer. Now let's take the next question. Hope you have understand each and every step. Okay, yeah, the question is bit lengthy. Okay, it will require practice to solve, okay, this type of questions. You cannot directly solve this type of questions at single attempt. Now let's take the next question. Let me take the next question. The next question is as follow, which says z, if z equals to x log into x plus r minus r, where r square equals to x square plus y square, prove that dou square z by dou x square plus dou square z by dou y square equals to 1 by x plus r. Okay, so here first you should note down that this function is not a symmetric function. Okay, so here if you find dou square z by dou x square, okay, you cannot say that dou square z by dou y square can be obtained similarly. It will be entirely different, since it is a combination of this. Okay, here you can understand the path, okay, to reach x and y terms from z, which are main function. Okay, and z is a composite function. It is reaching to x and y variables through r. Okay, so first z is a function of r, where r is a function of x, y. Okay, so this thing you should be alert. Further on, we will write all the given things, which will be z equals to x log x plus r minus r. Now r square is equals to s square plus y square. Okay, now what we are going to do here is Okay, let's partially differentiate partially differentiate z with respect to what? First we are going to target our x term with respect to x. Okay, so if we differentiate, what we are getting, dou z by dou x will be what? It will be x. We are going to obtain its differentiation using product rule. So x into dou by dou x log x plus r, and further if I move on, it will be log x plus r into dou by dou x into x, right? And here it will be dou r by dou x. Now you can significantly see and observe that dou r by dou x, okay, which is the required thing, you can obtain this by from here. Okay, so r square is nothing but x square plus y square, so r will be nothing but x square plus y square. Further on, what we can say is, if I differentiate dou r by dou x with respect to x, we are getting 1 by under root 2 x square plus y square, which we can say here by chain rule it will be 2x, giving me x by r. So similarly here, by observing, there will be a point we will require dou r by dou y, which will be nothing but y by r. Okay, since this function is symmetric, not this function is symmetric. Okay, further on, what we can observe, that if we continue with this by substituting these values, what you will see, it is x plus r, and here by chain rule it will be 1 by dou r by dou x, and here it will be log x plus r into 1. This will become 1 minus dou r by x is nothing but x by r. Further on, if you observe carefully, x plus r into 1 plus dou r by dou x is x by r, and here 1 plus log x plus r minus x by r. Now further on, if we simplify, this will be x into r plus x the whole by x plus r into r, and here log x plus r minus x by r. So here this and this will nullify, giving me finally x by r plus log x plus r minus x by r. So you can significantly see, okay, and make out that these terms and these terms will nullify, and giving me finally log x plus r as our main thing. Now you got what? Dou z by dou x. Now what we are going to do? Partially differentiate, call it as 1 with respect to x. What you are going to get? Dou square z by dou x square, which will be what? 1 by x plus r, and here 1 plus dou r by dou x, giving you finally 1 by x plus r. Here it will be r plus x by r. So this and this term will cancel out, and you are getting 1 by r. So you will call it as sum 2. Now we are going to get this second term. Since the function is not symmetric, we have to obtain this term, okay, again. So partially differentiating y with respect to x, we get, what we get is nothing but, z with respect to y. Okay, sometimes these questions are so lengthy, okay, that if you attempt them, there is very high probability that you make mistake. Okay, even a small mistake will directly lead you to the negative answer, straightforward. So here, if I solve this by partial differentiating y, I am going to get dou by dou y log x plus r, and since I am not partially differentiating with respect to x, there will be no product rule involved, and I will directly move on to dou r by dou y. This, after this we are going to get to x plus r, and this will become 0, and this will become dou r by dou y, and this will be this, and I have already told you it will be nothing but y by r. If I simplify further, x by r plus x, what we have, this is y by r, and this will be y by r. So if I take y by r as my common term, I will be left with x by r plus x minus 1. If I simplify, I will be left with y by r into x minus r minus x by r plus x, which is giving me minus r will cancel out, minus y by r plus x. So this is my required thing, which is dou z by dou y. Now what we are going to do is partially differentiate it again with respect to x. So I will call it some 3. Okay, now partially differentiate 3 with respect to y. What you are going to get? Dou square z by dou y square, which you can write dou by dou y into dou y by dou z, which was nothing but. And now if you observe, you are going to use quotient rule to solve it out, because r has both x and y terms. So it will be x plus r the whole square. I will keep the negative terms outside, giving r plus x, and here it will be dou by dou y minus y will be outside this time, and here dou by dou y into r plus x. Okay, so if I further solve it, I am going to get x plus r, this will become 1, this will become y, this will become y by what? Y by r, and this will become 0, and here I will left with x plus r the whole square. So if you observe and if I multiply, I am going to get xr plus r square minus y square, okay, the whole by x plus r the whole square. Now if you observe here, many children will get stuck and they will think what to proceed after this step, because they cannot, because if you observe, r square is nothing but x square plus y square. So if I substitute, my y term will move out and I will be left with xr plus r square, x square, and here it will be x plus r the whole square. And if I take x outside, so what I am getting, it x plus r the whole upon x plus r the whole square. This r and this one r will nullify, giving me finally x by minus x by x plus r. So my dou square z by dou y square is nothing but this stuff. Now what we wanted to prove, we wanted to prove dou square z by dou x square plus dou square z by dou y square is this result. Okay, so what our main aim will be, we are going to substitute this stuff, which I will call it as, what we will call it as, what was the okay, just call it as 3. Now let's substitute the things. So write it again, dou square x by dou z by dou x square plus dou square z by dou y square. We are going to substitute the values respectively, which will be, for the y will be minus x by x plus r, and for z will be what? If I substitute the value, it will be, where is the value of x? Okay, let me search. I cannot find the x value. This is my y value. Where is my x value? Yes, it is 1 by r. So if we simplify out, what I am getting is let me see, this is the dou square x by dou square 1 by r, and okay, so this is 1 by r only. And let's see the proof, x plus r is the required thing. So if I simplify, x plus r minus xr the whole by r into x plus r. So what we are going to get from here, so are we doing any mistake? Let's check out. Okay, here many terms are not cancelling out. Okay, let's see. Yes, we are doing a mistake here. R is multiplied when here there will be one r term also. So finally there will be one r also. So if I simplify, here it will be r into r, and this step will be simplified. It will be this, x plus r minus x by x plus r, which if I simplify further, 1 by r into r by x plus r. So you can clearly see 1 by x plus r as our solution. So which is the required thing which we wanted to prove. So hence we have proved this result. Now let's move on to the next question. which is probably the last question of this session. The question says, if u equals to 1 minus 2xy plus y square the whole power minus 1 by 2, prove that dou by dou x into 1 minus x square into dou u by dou x bracket plus dou by dou y into y square dou u by dou y bracket equals to 0. So first write what is the given thing to xy. Whenever this type of question appears, there will be one thing which you should always know, okay, but first we want to find this thing. So partially differentiate u with respect to x. What you are going to get? Dou u by dou x, which will be what? Which will be nothing but minus 1 by 2, 1 minus 2 xy plus y square. Here it will be minus 3 by 2, giving you here, if you differentiate it with respect to x, you will be left with minus 2y. If you simplify, your answer will be y into 1 minus 2xy plus y square, okay, minus 3 by 2. Now you can clearly observe, this is my, if I multiply the whole power, if I take the cube on both sides, this thing is nothing but u cube. This type of question we have done earlier, so I can write it as u cube. Whenever this type of question appears, when dou u by dou x or dou u by dou is multiplied and then further differentiate, you have to convert, okay, write this term in this format so that your task becomes easy, okay. Otherwise, if you keep substituting this big thing, there is very high chance that you make a mistake. So this is what dou u by dou x. Now I will multiply by 1 minus x square throughout. What we get throughout, if I multiply, what we get, it will be 1 minus x square dou u by dou x, which will be nothing but, if I multiply 1 minus x square y into u cube, which will be nothing but y minus y x square into u cube. Now call it sum 1. Partially differentiate 1 with respect to x. What we get? So if I differentiate it, what, okay, so if I differentiate it with respect to x, what we are going to get is dou by dou x into 1 minus x square dou u by dou x, this whole bracket, which is this stuff. So what I'm going to do, I'm going to apply chain rule. What will be 1 minus y x square, this will be differentiated with respect to this, and further on this will be kept as it is, and dou by dou x, this will be differentiated. If you observe, what I'm going to get is this stuff, 3u square into dou u by dou x. Further on, here u cube, this will become 0, this will become minus 2xy. Further on, we will substitute this value from what? From here, which will give me y minus y x square 3u square into y u cube plus u cube minus 2xy. If I simplify, 3u power 5 y minus y x square into y plus u cube 1 minus 2xy. If I further simplify, what I am going to get is 3u power 5 into y square minus y square x square plus bracket u square minus 2xy. So this is my 3 or second equation. After this, what we want to find? We want to find dou u by dou y. So partially differentiate u with respect to y. Dou u by dou y will be what? Minus 1 by 2, 1 minus 2xy plus y square minus 3 by 2. Here it will be minus 2x plus 2y. If I simplify, I am going to get x minus y into 1 minus 2xy plus y square, the whole power minus 3 by 2. If you further simplify, you are going to get x minus y, the whole u power 3. Now what they have told, multiply throughout by y. Multiply throughout by y square. you get y square dou u by dou y. Here y square into x minus y into u cube, giving you finally y square x minus y cube into u cube. So now partially differentiate 3 with respect to what? Y. What we are going to get? Dou by dou y into y square into dou u by dou y. Okay, which was this thing. So if I differentiate it using product rule, x minus y cube, here it will be dou by dou y into u cube plus u cube into dou by dou y into y square x minus y cube. If I further solve it, y square x minus y cube 3u square dou u by dou y, okay, plus u cube. This will be 2y x minus 3y square. If I further simplify it, I will substitute this value, y square x minus y cube 3u square dou u by dou y. Dou u by dou y we are going to substitute from where? From this x minus y into u cube plus u cube into 2xy minus 3y square. You can clearly see what we are going to multiply each and every term. 3y power 5, okay, will be what? X into y square x minus y cube minus y into y square x minus y cube, okay, plus u cube 2xy minus 3y square. If I further solve it, what I'm going to get? I'm going to get 3u power 5 y square x y cube minus y power 3x plus y power 4, okay, y power 4 plus u cube 2xy minus 3y square. Now call it some fourth. Add what? Add 2 and 4. If I add, I know 3u power 5 and 3u power 5 is same, and I have to add this stuff with this and this stuff with this. So if I add, which will be what? Okay, which will be dou y dou x of 1 minus x square, right? What it was? 1 minus x square dou u by dou x plus dou u by dou y into y square dou u by dou y, which will be 3u power 5. Okay, you can clearly make out by here that all which terms are cancelling out. This and this will cancel out. This term will remain. So the terms which are left are this and this term will cancel out. Okay, this and this term will become twice. Y square minus twice xy. Twice xy cube. Twice xy cube plus y power 4 is left here, and y u cube. Here it will be what? This and this will cancel out. I will live with 3y square. Now what we wanted to prove, it is equal to 0. So if I take y square outside, I will be left with this thing, which will be nothing but 3u power 5. If I take y square outside, I will be left with 1 minus 2xy plus y square plus u minus 3y square. Now you can clearly see this is nothing but 1 by u square. So this will become u cube y square, and this is nothing minus 3y square u cube. So this and this will cancel out and give me 0 answer. Okay, this is what? U is what? U is 1 minus 2xy plus y square the power minus 1 by 2, which I can write as u equals to 1 by 1 minus 2xy plus y the whole power 1 by 2. If I square, I am going to get u square is equals to 1 minus 2xy plus y square, which is this, which I want. Its value will be what? Its value will be 1 minus 2xy plus y square will be nothing but 1 by u square. So I am going to substitute this value, which will give me 0. So hence we have proved all the 3 questions. Okay, you can check all the 3 questions clearly and try it on your own self. Okay, all the questions are lengthy. Okay, and it's what engineering mathematics is all about. So hope you have enjoyed the lecture. Now let's see you in the next lecture. Till then, revise these all the questions which we have done. Okay, and don't forget to share and like the channel. Thank you. See you in the next lecture.